Receptacles cannot be mounted in 1.5-inch deep boxes. Receptacles cannot be mounted in a switch box either. Electrical boxes have specific volume requirements based on the number and size of conductors, devices like receptacles, and internal components like clamps or support fittings that are present within the box. The National Electrical Code, or NEC, dictates these requirements to ensure safe and reliable electrical connections. Using an undersized box can lead to overcrowding, which in turn can cause several problems. Firstly, it can make it difficult to properly and safely connect the wires to the receptacle. There needs to be enough space to manipulate the conductors and make secure terminations. Cramming wires into a tight space can put stress on the connections, potentially leading to loose connections or even short circuits. Secondly, overcrowding can hinder heat dissipation. Electrical components generate heat as current flows through them. In a confined space, this heat can build up, potentially damaging the insulation of the wires and the receptacle itself. Over time, this can lead to premature failure of the components or even create a fire hazard. Thirdly, the NEC mandates minimum box fill requirements to prevent damage to conductors and ensure the safe operation of electrical systems. These requirements are based on the volume of the box and the number and size of conductors and devices installed within it. Using an undersized box violates these code requirements and can result in fines or other penalties. The term switchbox generally refers to a standard single-gang electrical box commonly used for mounting switches. These boxes typically have a smaller internal volume than boxes designed for receptacles. Receptacles, especially those with larger wiring terminals or internal components like ground fault circuit interrupters, or GFCIs, often require more space than a standard switch box can provide. Therefore, it is generally not permissible to mount a receptacle in a standard switch box. When selecting an electrical box for a receptacle, it is important to consider the following factors. 1. The number and size of conductors that will be entering the box. Each conductor, including hots, neutrals, grounds, and equipment grounding conductors, contributes to the box fill calculation. The NEC provides tables, such as Table 314.16, that specify the volume allowance for different sizes of conductors. 2. The number of devices, such as receptacles, switches, and dimmers, that will be installed in the box. Each device also contributes to the box fill calculation. The NEC typically assigns a volume allowance of 2 conductors for each device. 3. The presence of any internal components, such as clamps, support fittings, or cable connectors, that take up space within the box. These components must also be factored into the box fill calculation. 4. The minimum depth requirements for receptacles. Receptacles typically require a minimum box depth to ensure that they can be properly mounted and that the wiring terminals are adequately protected. Using a box that is too shallow can prevent the receptacle from sitting flush against the wall or surface, creating a safety hazard. To determine the appropriate size of an electrical box for a particular application, it is necessary to perform a box fill calculation. This involves adding up the volume allowances for all conductors, devices, and internal components that will be present within the box. The total volume must not exceed the maximum volume of the box, as specified by the manufacturer or the NEC. If the initial box selection proves to be too small, it may be necessary to upsize to a larger box or use a box extension to increase the available volume. There are different types of electrical boxes available for mounting receptacles, including metal boxes, non-metallic boxes, and gangable boxes. Metal boxes are typically made of steel or aluminum and provide excellent mechanical protection for the wiring and devices. Non-metallic boxes are made of plastic or fiberglass and are lightweight and corrosion resistant. Gangable boxes are designed to be joined together to create larger boxes for multiple devices. When installing a receptacle, it is important to follow all applicable electrical codes and safety standards. This includes ensuring that the box is properly grounded, that the wiring connections are secure, and that the receptacle is mounted correctly. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the installation. In summary, mounting a receptacle in a 1.5-inch deep box or a standard switch box is generally not permitted due to insufficient volume and potential safety hazards. It is important to select an electrical box that is appropriately sized for the number and size of conductors, devices, and internal components that will be present within the box. Always follow all applicable electrical codes and safety standards when installing receptacles. The NEC provides detailed guidelines for box fill calculations and receptacle installation requirements. When selecting an electrical box for a receptacle, consider the following factors: the number and size of conductors entering the box, the number of devices installed in the box, the presence of any internal components, and the minimum depth requirements for receptacles. There are different types of electrical boxes available for mounting receptacles, including metal boxes, non-metallic boxes, and gimbal boxes. Always ensure that the box is properly grounded and that the wiring connections are secure. If you are unsure about any aspect of receptacle installation, consult a qualified electrician. Properly sized and installed electrical boxes are essential for ensuring the safety and reliability of electrical systems. Overcrowded or undersized boxes can lead to a variety of problems, including overheating, short circuits, and fire hazards. By following the NEC guidelines and using appropriate electrical boxes, you can help to prevent these problems and ensure the safe operation of your electrical system. Always disconnect power before working on any electrical circuits. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use insulated tools to prevent electric shock. Inspect all wiring and devices for damage before installation. Do not overload electrical circuits or boxes. If you notice any signs of electrical problems, such as flickering lights, sparking outlets, or burning smells, immediately disconnect power and call a qualified electrician. Regular maintenance and inspections of your electrical system can help to prevent problems and ensure your safety. By following these guidelines, you can help to ensure the safe and reliable operation of your electrical system. Always prioritize safety when working with electricity. If you are not comfortable performing any electrical work, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others.